Alright, so we're going to be working on projectile motion with drag. The end result, we want to be able to get the path that the ball is going to make within the air. We're utilizing Excel here because we're going to actually have to recalculate, do multiple calculations on this on an interval. The reason is that the drag is going to impact the acceleration of the ball throughout its path. And so the more we calculate, the more accurate the data that we're going to get. Another unique thing is that while the ball is going up, in the y direction, gravity is working against it. But when we actually start going down in the y direction, gravity is working with it. So I've gone through and we've already built this out. And so what's going to happen is you can use a screen capture here to check your work as we go along. And I'm going to work on this setup over here as far as things go. So what we have is we have our variables broken out into our modifiable things. So if I wanted to change my initial velocity or the angle I fire at, I'm more than willing to do so. I can change the time interval if I want. And if my device is going to be on a table, I might want to change my Y position. I grade out anything with a formula or anything that you probably don't need to change. And so I don't foresee you wanting to change the ping pong ball. And so I've graded that out. I don't foresee you wanting to work on the moon, and so gravity is grayed out. And also we're going to stay in Kentucky, so the density of the air is going to stay pretty consistent. We have our coefficient of drag right here, which is at 0.7, and we're going to calculate our drag constant without our velocities here. That's going to allow us to apply it a little bit easier to this acceleration drag calculation later on. So to do that, I'm going to type in equal, right? I'm going to type in negative 0.5, and we're going to multiply that against the density of the air times the coefficient of drag times our area. And I should get a number that means very little to me. It's just a very, very small number. We're dealing with a smooth surface, so that makes sense. When we go down here, I'm going to go and start with my duration. So we're going to start at 0 seconds. And I'm going to build in right here. I'm going to type in equals. I'm going to take my 0 seconds and I'm going to add my time step. And what I'm going to do is I'm going to fill this down a little bit and you're going to see an error. And so we can see that it doesn't go 0.01, 0.02. The reason is that if I go into this cell, it's effectively just shifting down with it. So I need to intentionally, as we're building this up, I'm going to push F4, and what that does is it puts dollar signs in front of it, and that's because that cell is just more valuable. In other words, it locks it in for it. And then when I fill it down, we should see 2, 3, 4, 5 as far as we go. I'm now going to type in angles, right? Enter. I'm then also going to do my radians, which is this value right here. Excel is going to work in radians, so whenever I'm doing math with it, I'm going to have to convert my degrees to radians. I just feel more comfortable looking at degrees just for my conceptual understanding, and so that's why I have that there. So now on my velocity here, I'm going to type in equal, and this is going to be my initial velocity right there, and I'm going to multiply it by the cosine of my degree in radians, or my angle in radians. Right? I'm going to do the exact same thing here. I'm going to use this. I'm going to take my initial velocity. I'm then going to multiply that by sine of the degree in radians, or the angle in radians. Right? And effectively what I'm doing there is I'm just finding Vy and Vx. I'm then going to bring in my X and Y positions. So my first X position is right here, right? My first Y position is equals right here. And so now I'm going to work on the acceleration to drag in the X direction. So I'm going to type in equals. I'm going to select my constant. I'm moving up there, so I'm going to push F4. And then I'm going to multiply it by my velocity in the X direction, which I am going to square. The caret is above the 6, if you were wondering. And then I'm dividing it by its mass right there. and I'm pushing F4 again. Right? Once I have my acceleration here, I can go and work about my final velocity. And so I'm going to type in equal. I'm going to take my velocity in the x direction. I am going to add it to my acceleration times my time constant. And again, I'm reaching up here, so I need to be intentional about pushing F4 to lock that in. So we can see it's slowing down, so that's a good thing. I'm then going to check and determine my change of distance that I've got. And so to do this, I'm going to take the average of my final velocity, comma, and my initial velocity, right? And I am going to multiply it by that same time constant again pushing F4. Right, so very small number as far as that goes. And so we're going to check that to make sure we're good. So 0.06875, 0.06875, perfect. And now we have to develop our if statement. So I'm going to type in equals. I'm going to type in the word if. And it's going to give me some things. I've got a logical test. My logical test is going to be, is it moving at a velocity upward or downward? Right? And then I'm going to develop this structure or this calculation with gravity dependent on which direction it's going. So here we go. So my logical test is going to be, is this greater than 0, right? And then if it is, I'm going to take my gravity here. Again, I'm clicking up there, so I'm pushing F4. I'm going to add that to my constant, again, pushing F4, times my velocity, again, the y direction here. So we're doing up and squared, and I'm dividing it by my mass, again pushing F4. If it's going down though, right, so the negative number, so it's going down, what I'm going to do is I'm going to take, again, my gravity, again pushing F4, subtracting my drag constant, multiplying by the initial velocity here, squaring it above the 6 again, and then dividing by the mass, again pushing F4. I can now close out my bracket and push enter. With that complete, I can now finish out my final velocity in the y direction and the change of distance in the y direction. So to do that, I'm going to type in equals here. I'm going to take my velocity in the y direction, which is 4. I'm going to add it to parenthesis my acceleration, and I'm going to multiply that by my time step, again pushing F4 and clicking enter. I'm then going to go in and do my distance. Again, it's going to be the average. It's going to be the average of my final velocity and my initial velocity. And I'm just going to multiply that by the time constant, so I'm getting the middle area or the middle speed there, and that's going to be an F4. Then I'm going to calculate my final velocity, and so to do that, I'm just going to use the Pythagorean theorem. So I'm going to take the square root of a squared plus b squared. Right? And then to get my final angle, what I'm going to do is I'm just going to take the inverse tangent. That's a tan. And I'm going to take the two values there into it. All right, and I see it's going down, so that's good. All right, now addressing the second line, what I'm going to do is the second interval, my initial angle is this one right here, right? To make this make sense to me, I'm going to type in degrees, parenthesis, and then the angle that I'm working with. Right there, I can see my angle going down, which is great. My initial velocity is going to be my final velocity here. My initial velocity here is going to be my final velocity here. My x position here is going to equal this plus that. My y direction is going to equal this plus that, so the change in it. I'm going to check right here to see if we can pull this down, which we can. So this one's going to reference the cell over there. I can see that change. This one's going to reference the cell over there. I can see that change. Let's check this. I get, all right, those are all locked in right. And so I should be able to pull that down. Should be able to pull this down. And I believe the rest of these I can also pull down. And the reason that is because they're only referencing values that are in that row. So with that in place, I can fill those numbers down. I do want to point out I made an error, which is I didn't lock down this K48 right there, and so it had issues. So if you fill down and you start seeing errors or just numbers, just NUM, that might be the problem. So I'm going to pull this down here, right? I'm then going to grab my 0.5 and pull it down the rest of the way also. All the way to 100. Perfect. With that in place now, I want to add some conditional formatting here for me. The first one is going to be on this row right here. That is the one that's referenced for this acceleration. And so I'm going to go to the home, conditional formatting, highlight cells rules, anything less than. I'm going to type in 0, and I just want to make that yellow just so I can see where that changes. And so I can see that between 0.36 and 0.37, that's the moment it starts going down. The other conditional format I want to put in here is on the Y position. And what I'm going to do here is do the exact same thing. I'm going to go into home. I'm going to do a conditional formatting less than 0. In this situation, I'm going to make it red. And what's going on there is it's showing me when it hits the ground. So this is going to hit the ground between 0.78 and 0.79. So the last thing to do here is to make a graph. So I'm going to highlight the Y's here. And I'm going to go and insert. I'm going to go into line graph. It gives me that, which is great. I'm then going to go in and modify my data. So I'm going to select my data. My edit here is going to be selecting the duration in seconds. We're going to click OK. Let's click OK and see what that looks like. All right, and now all I need to do is just make this look pretty effectively. And so I'm going to go in. I am going to modify my values here. I am going to set my axis bounds to 0 because I don't really care about what happens after the fact. My maximum can be auto as far as things go. I can play with the tick marks if I so desire, so I can add a cross for those, and I can add a inside tick mark here if I so desired, if I think that looks pretty. So then I'm going to work on the bottom here. And I can go in, I can manipulate tick marks if I want. I can also change how many of those there are. So I'm just going to specify interval unit, which is 10, which should give me that, which is a little easier to work with. I'm also going to set my number to have a number, but I want there to be 2 places. Last thing to do, it does not need a title, so I'll get rid of that. And I'm going to add a axis titles. Seconds. And this is Y position in meters. Now, there's definitely different ways I can dress it up, and I'll let you take liberty however you want to do that. But this way I'm able to go in and change my velocity. And I can see how that modifies my graph. I can change my angle and see how it modifies it, which is going to hopefully make it a very effective tool for us. Good luck with it.